let's continue where we left off. We have the next elements. So we have the focus, also called the focal point. So take note that the focus is a point. Okay, so it's a point away from the curved line. In this scenario, our parabola is the curved line around which the parabola bends. Okay, if you try to see or observe our parabola, the bending of the parabola depends on the location of the focus. So try to observe or try to imagine if our focus is here, what do you think will happen? Or if our focus is here, what will happen to the parabola? Okay, so you will see later on in our graph, so what will happen. Okay, the next, it's the intersection of the axis of symmetry and the latus rectum. Okay, so we have now the word latus rectum. We are going to discuss this one later, but we just need to take note it's an intersection. Okay, it's the intersection of the latus rectum and the axis of symmetry. So again, in this scenario, our axis of symmetry is this black line here, and the latus rectum is actually the line that passes through the focus, and it's always perpendicular to the axis of symmetry. Okay, so that's the latus rectum. Okay, next, it is always a distance of P away from the vertex, of course, because P is the focal distance. Remember, P is the focal distance. That's why it's called the focal distance, because it's referring to the focus. And it's away, P away from the vertex. So we have some notations here. So our notation for the focus, because it's a point, we use the capital letter F. So we have H plus P, K, if the axis of symmetry is horizontal. Okay, so try to imagine if the axis of symmetry is horizontal, what is the opening, or what direction does the opening of the parabola looks, or where is the parabola opening? Okay, so you're correct. If the symmetry is horizontal, it's opening either to the left or to the right. If the symmetry is vertical, it's opening upwards or downwards. So in this scenario, our axis of symmetry is vertical, hence the opening is upward. Okay, so we have this for the focus. Just try to remember this. So shortcut to remember where to add the focal distance. So here, if it's horizontal, left or right, just add it to the horizontal movement, H. Again, H is the horizontal movement, you can remember. If the axis of symmetry is vertical, it's upwards or downwards, add the focal distance in the vertical movement, which is K. You can remember K is the vertical movement. So, just some tips to remember. Next, we have the directrix. Okay, so the directrix is a line. So if it's a line, it is in equation form. So it's a line used to construct and define a conic section. So remember this, that all of the conic sections have a directrix. It just depends on the location of the directrix. And in fact, for the parabola, so the parabola has only one directrix in this scenario. It's because the directrix of the parabola, the other directrix of the parabola, goes to infinity. Okay, so it's undefined, in other words. So we have the notation for the directrix. We have x equals h plus minus p. So if the symmetry is horizontal, and y equals k plus minus p if the axis of symmetry is vertical. So where is the directrix here? It's actually this broken line here. Okay, in our scenario, this is the directrix. Okay, so some tips to remember where to add the focal distance. So if again our parabola is opening left or right, we will use x equals h here. Okay, x equals h, because remember, x and h refers to the horizontal movement. H is for the horizontal movement, x is in the horizontal axis. So we will add or subtract p in the horizontal part, or x equals h. So meaning the line passes through x equals h. Okay, so x equals h plus minus p, sorry. Next, if it's vertical, we will add or subtract our focal distance p to the vertical movement, because it's upwards and downwards, vertical. Okay, so we have y equals k plus minus p. Okay, so the focus and the directrix are actually, try to observe, opposites of one another. If the focus is upwards, the directrix is found in the bottom. If the focus is found in the bottom, the directrix is found at the upper portion of the graph. Okay, if its focus is at left, directrix is at right. If the focus is at right, the directrix is at left. And now let's move towards the last part. We have the sixth element, the latus rectum. Okay, so what does the latus rectum mean? So the latus rectum just means it's a straight side. Okay, it's a line segment, in fact. Okay, so latus means side, rectum means straight. That's why when you say rectangle or rectify, it's straight. Okay, rectify is to straighten up. Okay, latus is a side. Then it's a segment which passes through the focus. So this is actually the segment here, the blue segment here. Okay, that passes through the focus. Okay, it's parallel to the directrix. So directrix is the black line here. Okay, parallel, and it's perpendicular to the axis of symmetry. The axis of symmetry is the red line here, the horizontal red line. Okay, in our example here. So the length of the latus rectum is actually the absolute value of 4p. So the total length of this here, okay, the blue line, total length of this one is actually 4p. And we take the absolute value because we're referring to the length. Again, there is no negative length. It's just positive length. Okay, so some small observations, you will realize that half of this latus rectum, what will be the length of half of the latus rectum? It's actually just 2p. Okay, it's actually just 2p. So you must remember this, the semi-latus rectum, because it's very important in locating the endpoints of the latus rectum. Okay, so we have the endpoints here. This is the endpoints of the latus rectum, and the endpoints of the latus rectum intersects our parabola. Okay, and this will actually define the opening of the parabola. So the length of this, okay, the length of the latus rectum and the position of the latus rectum defines the opening, the bending of the parabola. And that's it for the elements of the parabola. So before we end, let me leave you some question to answer. So can you enumerate all of the elements of the parabola and give a short description about the elements? Okay, again, enumerate all of the elements of the parabola that we have discussed and give a brief description of these elements. So you may answer it after this video. So in the next video, we are going to discuss the standard forms of the parabola. We're going to deal now with the equations, the formulas of the parabola. See you there. Bye-bye.